Hello, in this video, we are going to talk about the 2022 WASSCE Physics Practical. And this will be a series, and we're going to start with mechanics. For mechanics, there will be two sections. We're going to start with the explanation side of it. Then, in a subsequent video, we'll talk about the experiment proper. We'll actually simulate the experiment. So let's start off with mechanics, the explanation aspect of mechanics. So for the 2022 physics practical in WASSCE, these are the apparatus you should be expected under mechanics. This should be the first question, right? So you should be expected to see a meter rule, a knife edge, a piece of string, a weight hanger, and a set of masses. The piece of string could be a single string which you might be asked to split into two, or it could just be a single string which is meant for just a mass. So, but we are going to look at an example that will throw more light as regard what you're expected to do. So let's talk about the objective. So what's the objective of this kind of experiment? In general, this kind of experiment is meant to help you determine the mass of an object using the principle of moment. So before we dive deep into this video, let's start off by talking about the principle of moment. Then we'll talk about how Waec is expecting you to use that principle to figure out the mass of an object. Then we'll talk about which object in particular are they interested in making you find, right? And how would the experiment guide you towards that? So that's what I'm going to discuss in this video. So let's start with the principle of moment. So let's look at this scenario. So if you have a knife edge here, if this happens to be a knife edge and you have your meter rule placed here, let me explain what the principle of moment is using this diagram. So let's say you have a mass on this side. You have another mass on this side. Let's call this M1 and let's call this M2. The force along this side is F1, and this F1 is M1 times acceleration due to gravity. And the force acting on this object is F2, which is M2 times acceleration due to gravity. So what the principle of moment states is this: the sum of the clockwise moment must be equal to the sum of the anti-clockwise moment, given that the system is in equilibrium. So let me first talk about what is a moment. Then we'll talk about clockwise and anti-clockwise. So moment is simply the product of the force times the distance to the pivot point, to the pivot point. So this is the pivot point. That's the point where we have the knife edge. So let's say this is G, right? And let's say this distance is D1. And let's say this distance is D2. The distance between the point at which the force is acting and the point, the pivot point. The pivot point is basically the point where the object tends to rotate, right? Now, the moment is simply force times distance. Moment is also known as torque. Sometimes you hear a word like torque, right? It's also the same thing as moment. So now, when you look at let's take a look at the direction in which the two moments are acting. The one on the left, which is F1, think about it. If you pull this meter rule on this left side, it tends to rotate this meter rule in an anti-clockwise direction. What that means is it tends to rotate this meter rule in an anti-clockwise direction, whereas F2 tends to rotate it in the direction of a clock, that is clockwise direction. So what the principle of moment is stating is, if this meter rule is at equilibrium, meaning it's not moving to the left, it's not rotating to the right, it's just static, right? What the principle of moment states is that F1 times D1 must be equal to F2 times D2. But there's a catch here. The catch here is that we are assuming that the weight of the meter rule is acting along this pivot point. If the weight of the meter rule is not exactly at the point where we have the knife edge, then the weight of the meter rule will be considered when you are applying the principle of moment. So let's take a look at this scenario. So let's say we have our meter rule as before. But this time around, let's say the center of gravity of this meter rule is here, right? So let's say this is mass. It has a mass of m naught. So let's say the knife edge is away from this center of mass of this meter rule. And let's say this point is point P, right? Now, we have a mass or a force acting along this direction, F1, right? Then we have a force downward, which is the mass we have here, right? There's a mass here, and the force is F2. Now, the distance from this F1 to the pivot point is D1. The distance from this F2 to the pivot point is D2. Now, if you want to apply the principle of moment, what you're going to do is you are going to factor this weight of the meter rule. And the weight of this meter rule is going to put into consideration. So this can be said to be D naught, right? The distance between the center of this, the center of mass of this meter rule and the pivot point is D1, is D naught. So how do we get the equation that applies the principle of moment? So the first one we do is we want to ask where are the clockwise or anti-clockwise moments. So let's start with the clockwise moment. Which moment tends to rotate this meter rule in a clockwise direction along this pivot point? Now, if you check it closely, you see that this tends to pull this in a clockwise direction, while F1 tends to pull in an anti-clockwise, and this M naught, which is the mass of the meter rule, tends to pull it across anti-clockwise. So we can say that F1 times D1, which is the first moment, plus this is M naught, so we can say this is F naught, right? So F naught times F, note that F naught is M naught times G, which is acceleration due to gravity. So F naught times the distance between that center of mass and the pivot point, which is D naught. This must be equal to F2 times D2. So this is the equation that represents that is as a result of the principle of moment. And with this equation, you can determine a lot of things. So now this is just to illustrate what the principle of moment state, but this time around in a very practical sense. Now that we've talked about the principle of moment, so what do you think this experiment will help us achieve? Like, in other words, how can we determine the mass of an object using this principle? So what Waec is going to do, they can give you a lot of questions in different ways. They can set the question in different ways. But generally, one of the masses will be unknown. So, for example, I could make the mass of the center of mass to be unknown. So, in other words, I could say this meter rule mass is unknown. And if it's unknown, I can figure out the value of the mass of the meter rule within this formula. In other words, if I know F1 and I know F2, then I can solve for M naught. But generally, you're not going to be expected to solve. You're going to be expected to get some data that will eventually lead to a graph or an equation. Eventually, you get the value of M naught. But the point I'm just stressing here is it is either the question will lead towards determining M naught. And what WAEC does is they will not tell you directly, but they will lead you by making you determine the slope or the intercept. Then from the slope or intercept, they will ask you to calculate something. That something is sometimes related to what they want you to achieve eventually. Well, in this case, that thing may relate to the mass of the meter rule. But there are times that they may also want you to look for the mass of one of these two objects. For example, this M1 could be known while M2 is unknown. You understand? So there are several objectives that could be extracted for, but generally the objective is around figuring out the mass of one or more of these masses. So that is what you should have at the back of your mind. Now that we've talked about the objective, now let's take a look at an example. So I'm going to take an example of what you would likely be expected to do. And this example will incorporate two possibilities into one. So I'm trying to take two possible ways the question could be asked into one so that you'll be able to explore those two possible cases. So what are my two possible cases is this. It's possible that Waec simply wants you to just have this M naught, right? Maybe this is maybe the knife edge could be here, and this is the center of mass, right? And this is M naught acting downward. And Waec could just tell you, okay, there's only one mass, right? Now, and this mass, you'll be moving it accordingly. In other words, Waec may tell you to adjust the meter rule. Maybe instead of the distance being 10 centimeters, they could say, okay, change the location of this knife edge. Then try to look for the position where this M1 will balance this meter rule. So you may just be dealing with just one mass that you are balancing, whereas the counter mass will just be the mass of the knife edge. In some other cases, they could tell you to balance two masses. So you could have a case where you adjust M1 and you have your knife edge here, and you're also adjusting M2. So this could be another possibility where you are not just adjusting one thing, you're adjusting two masses. You are moving one mass, then you move the other mass to balance the meter horizontal. So these are two possible ways they could be asked. Then there could be some slight adjustment, but generally it's either you are adjusting one mass or two masses at the same time. So, but I'm going to look at a scenario where you are balancing two, so that let's explore this interesting example, so that you gain a wider experience, so that even if you end up having just one mass, it will be quite easy for you to solve. Okay, so let's look at this example. So in this example, this is what we are working with. So let me draw the table so that you understand what we are doing here. In this table, there's going to be a P1, there's going to be a D1, then there's going to be a P2, and then you're going to have a D2. So these are the four key numbers you are going to be dealing with in this particular exam. This is a very interesting example, and Waec has said something like this in the past. So take a look at this. So how do we get P? What's P1? So this is how the experiment goes. This is the procedure. The first thing you want to do, the first thing you'll be told to do is to take a knife edge, right? Then you'll be told to note the center of mass of that knife edge. So let's say it happens to be at position 50. So this meter rule is of 100 centimeters, right? So let's say let's assume that the center of mass is at 50, right? So these are position 50. These are position 50. So let's say this is M naught, the mass of the meter rule. You'll be told to adjust this knife edge somewhere here, such that this distance is D naught. The distance between the center of mass of the meter rule and the pivot point is D naught. Okay. So the next thing you'll be told to do is to place the force mass. This force mass, which is M1, is known. So this is a known mass. So you know the mass. So they could tell you maybe 10, 20, 30, and so on. So this is a known mass. So you know this mass. Then they will tell you that once you set this at P1, P1 is the sum between 0.0, this is from 0 to 100. So the sum between 0 and here. So this could be like 20 centimeters, right? Or 10 centimeters, depending on the setting. So the first value could be something like maybe 10 centimeters, maybe 10 centimeters, 15 centimeters, 20 centimeters, maybe 30 centimeters, and so on, right? So they will tell you to position M1 at that point. Then the next thing they will tell you is to adjust M2. So this is M2, and this is unknown mass. Unknown meaning they will just tell you that, okay, you don't know the mass at the moment, right? Then you'll be told to adjust this mass until the knife edge, until the meter is balanced on the knife edge. So, but before we talk about M2 in detail, they will ask you to look for D1. So D1 is the distance between this this P1, that is the point where you have your first mass, and the pivot point, which is P, right? So the distance between where you have your first mass and the pivot point, that's D1. So let's say this is 10, and let's say this knife edge is at position, let's say it's at position 55, for instance. So since this is at position 55, it means you just remove 10 from 55. So this would be 45, right? So if you remove 15 from 55, you will get 40. So this is just going to be the D1 is simply the D1 is simply whatever the value of P is minus whatever the value of Y is. So Y is just the point where this M1 is positioned. So that's just what um, D1 is basically going to be. So you just subtract this from that 55. If P is at 55, right, 55 centimeters. So it means you just subtract all of this from 55, and that will give you this. So this would be something like 35, and this would be something like 25. So then what about the P2? P2 is the distance between the second mass and the 0 point on this meter rule. So you'll be asked to figure that out. So if you eventually balanced it at, let's say 80, for instance, then this you write 80. Then if you balance it at maybe 75, you write 75, and so on. So what about D2? D2 is designed between that, where you balance the second mass, the unknown mass, and the pivot point. So, and how do you get that? Just take this Q, this position Q, subtract P from it. So D2 is something like, take whatever value you have at position Q, subtract your value at P. Notice that P is 55, so just subtract 55 from whatever you have for P2. So just subtract 55. So if this is 80, then this will be, if you remove 55 from here, you are going to get 25, right? Then the same thing goes to, if you remove 55 from here, you're going to get 20, and it goes on like that. So this is how your table of reading will look like for this particular experiment. So this is a likely experiment you should be expecting. So this is how the table of reading will look like if it happens to be this. So now the issue here is, how is this data going to help us determine our objective of figuring out the mass? In this case, we have two unknown masses. We don't know the m naught, which is the mass of the meter rule, and we don't know this m2, which is the mass on the right hand side. So let's talk about the relationship between all of these masses and how this experiment could help you figure that out. I'm bringing this up so that you understand that experiments in WASSCE are not just for doing sake. You could learn a lot. It could help you actually be a good scientist, because this is how scientists actually figure out things. Whenever they perform experiment, they use experiment to solve problems. So I'm trying to show you how this experiment can be used to actually figure out uh, a real problem and solve such problem. So let's look at how we can use this kind of experiment to figure out the mass of the meter rule and the mass of the M2. So let's say this M2 is just one string mass, that we don't have any uh, let's say we don't have any weigh machine to weigh it, or let's say we want to build a weighing machine that uses the principle of moment to actually tell what the mass of an object is. So you can actually build a weighing machine that uses this principle to actually tell you what the weight of something is. So that is what I'm trying to explain here. So now let's talk about the theory behind this experiment and how all of these things are connected. Okay, since we now know the meaning of the P1, D1, and D2 and P2, let's connect everything together. So let's talk about the anticlockwise moment, the moment that tends to move this meter rule in an anticlockwise direction. So we have the F1, which is m1 times g. We have f naught, which is the force acting on the meter rule through the center of mass, which is m naught. M naught is the mass of the meter rule that we don't know, times g. Then we have f2, which is m2 times g. So the distance of each of this, which is d1, this is d naught, and this is d2. So what's the anticlockwise moment? This tends to go anticlockwise, this one tends to go anticlockwise, so we can say f naught d naught plus f1 d 1, they are the anticlockwise, right? Anti-clockwise moment. Then the F2 D2 is the clockwise moment. So we can equate both. According to the principle of moment, the anti-clockwise moment should be equal to the clockwise moment as long as the system is at equilibrium. So we can say that F0 D0 plus F1 D1 equals F2 D2. So the next thing I want you to do is let's substitute the n's and the g's. So if you do that, you're going to get something like this: m1 m naught g, then d naught plus m1 g and d1 equals m2 g and d2. You will see that g is common, so we can cancel out. We can divide all through by g. You can divide all through by g. You can divide all through by g. If you do that, you are going to cancel out all the g's, so you'll be left with m naught d naught plus m1 d1 equals m2 d2. Now that you've gotten this equation, the next is what will you be expected to plot? In this experiment, we're expected to plot d1 on the left. So let me just take this idea. Then I'm going to take this idea and we look at the next page. So here we have m naught d naught. Here we have m naught d naught plus m1 d1 equals m2 d2. So in this experiment, we're expected to plot d1 on the y-axis and d2 on the x-axis, and we're expected to make some plots such that eventually we're going to get something like this. Okay, let's say we have this plot, and eventually we're going to get something like this, where we are going to have a kind of y-intercept. This is the y-intercept, the point where it crosses the y-axis. Now, the slope of let's call the y-intercept, let's call it C. Then y-intercept is the value of d1 where d2 is 0. So let's call the slope S, right? Now, in general, it means the equation is meant to be something like this: d1 equals S. This is from the equation of a straight line. From the equation of a straight line, the value on the y-axis is always equal to the slope times the value on the x-axis plus the y-intercept. So if this happens to be C, which is y-intercept, then this is the equation of this line. So the question now is, how do we relate this to what we have here? So to relate that, you need to make d1 the subject of the formula. So if you make d1 the subject of the formula, you're going to get something like this. We have d1 equals m2 d2 minus m0 d0, then divided by m1 divided by m divided by m1. Okay, you will notice that throughout the experiment, d0 is a constant. We are not going to be moving d0. The knife edge is fixed, right? And because it is fixed, we will have a fixed d0. So this is a constant in this experiment. So eventually, the whole of this is a constant. Now you can see that if this is a constant, it means this C is equal to minus m0 d0 over m1. So we can easily know that this y-intercept should be something like this. So it means if you know your y-intercept, right, you can look for the value of any of this unknown. Since m1 is known, I can look for the value of m0, which is the mass of the meter rule. So if I've done my graph and I know the y-intercept, my m0, which is the mass of the meter rule, which is the unknown mass of the meter rule, will be equal to minus c times m1 divided by d naught. So, but in this, since m1 is a fixed, because m1 is fixed, we're not changing the mass of m1, so we can easily compute the m0 using this. Another thing you need to note is, what about if I want to calculate m2? m2 can be calculated from the slope. This represents the slope here. So it means S is equal to m2 over m1. So which means you may be told to look for m2 as follows. You may be told to look for the second unknown mass as m1 times S. So sometimes I could just tell you from your slope, calculate slope times m1. If they tell you that, they're indirectly leading you to calculating the unknown mass. So this is how you can compute the mass of the meter rule and the mass of m2, which is the second mass, using the principle of moment. So this is a very interesting explanation and as to how experiments can actually lead to you figuring out an unknown value using slopes and y-intercept from your graph. Let's talk about some of the precautions you should take note of whenever you're performing this kind of experiment. The first precaution is ensure that the meter rule is at equilibrium before taking reading. So don't just rush at taking reading. Make sure that your meter rule is horizontally stable before taking any reading. And the second thing you want to do is to make sure that error due to parallax is avoided when reading from meter rule. So make sure you position your eye in such a way that your eyes are parallel or are in parallel with the meter rule, such that you are not seeing a slightly you are not seeing the reading, taking the reading at an angle. You are taking the reading with your eye being parallel to the point where you want to take the reading. Then the third precaution is ensure that drought is avoided. Drought has to do with moving air, or droughts can be caused by moving fan or wind and all of that. Make sure you don't perform the experiment in a windy environment, because it will contribute to it will lead to imbalance, in the sense that the meter could tilt to one direction. In other words, it could tilt in the opposite direction of the wind, or it could just affect the stability of it, could make the meter unstable. And if it becomes unstable, it means you can't actually take reading. And it could also contribute to adding more force to one of the sides of the meter, which will make your reading eventually to be inaccurate. So the fourth precaution is ensure that the suspended mass do not touch the table before taking reading. So in other words, if your meter rule is placed on a knife edge, which happens to be on a table, make sure the thread or the string is not making contact with the table. If it is making contact with the table, you may end up getting a different result, because the friction between the string and the table might contribute to the reading you might eventually get, which may not be accurate. So ensure the mass is not touching the table, and the string as well is not making contact with the table, so that you don't get erroneous result. But in case you are asked to list precautions, don't list it the way you see it here. List it in a reported speech. So let's say you are asked to list precautions you took. You should say something like, I ensured the meter rule is at equilibrium before taking reading. I ensured error due to parallax was avoided. I ensured that drought was avoided. So try to present the errors as in a personalize it, and try to state it in a reported speech, not exactly the way it is stated here. So this brings us to the end of this section of mechanics. In the next video, we're going to talk about the actual experiment. We're going to simulate this experiment I just demonstrated theoretically, and we're going to see how you should carry out such experiment, and I'm going to show you how to plot your graph and every other aspect of it. So see you in the next video.